Today is the 17th of August 2023, and I would like to talk about relative frequency, which is also part of probability, because we've been doing probability in the last couple of lessons. Okay. Thank you to everyone who's been watching our videos. Okay, and please, depending on which platform you are watching from, can you please subscribe, share, like, follow, etc. So for instance, if you are watching from YouTube, you can subscribe, share, and like. From Rumble, you can also follow, share, and like. Okay, you can tweet it, retweet it. If you're on Facebook, you can watch and share. Okay, today is results day. Okay, and good luck to everyone who is taking their collecting their results today. Okay, but if this you are going to write next year or the year after, and our videos are helping you, I will encourage you to share. Okay, so that more people can watch. Okay, and it can help them as well too, because the chances are it will be helpful than less helpful, depending on what topic they are struggling with. Okay, so please, if you can help us on that and share the videos, it will be very, very much appreciated. I normally write in the comment section, please follow my notes/scripts. Okay, why? Because after I've finished recording, I watch it, upload it, and watch it again. Okay, these notes are mine. I normally do it, go over them several times, make sure. So when I'm presenting it, I basically follow the script. But at times, for instance, this is 500 students/parents. So if I'm doing this and I say 50, it's not 50, it's 500. Okay, that's 320. Okay, for instance, this is 2 decimal places, that is 8%. Okay, that is 0.17. so depending on that is 17%. So depending on whatever I'm explaining and I'm pointing, that is what I meant to say. So if you hear something other than that, then go by the script. For instance, 700 is the denominator, 118 is the numerator. So if it's something else and you heard it the other way around, please, you know what the numerator is and the denominator is, because I've done a video or two on that and on fractions. So please, 700 cannot be a numerator, it's a denominator. And 118, okay, cannot be a denominator, it's a numerator. Okay, so I'll appreciate your help on that. And then the third thing I want to say is scammers, which I'll have to say sometime, because I don't want you to get scammed. Okay, I won't send you a friend request, get access to your messenger, so that I'll say send you foreign numbers to donate money. It's not me. I won't do that. I won't chat with you on your messenger page. Okay, if you leave a nice comment for us, which I recommend that you do if our video is helping you, I'll come and say thank you or you are welcome, and that will be it. Okay, so beware of scammers. If somebody is saying to you, send us money for a orphanage, a charity, please, I don't have an orphanage, and I don't have a charity. Even if I want to give to a charity, there are some charities that I am passionate about that I'll give, but that is between me and them. I wouldn't be involving you, or maybe there is a disaster here, so send me money. It's not me, please, it's not me. Okay, it's not me. So don't fall for scammers. Don't send money to anyone. I wouldn't do that. I'm stressing on these things because I've had a few complaints. Okay, and it's not me. I haven't done that. Please don't. And fortunately, those people didn't. They knew me, so they told me. But please don't fall for these people. They are all over the place. Please don't. Now, a quick recap. We did probability earlier on in our videos, and then we started again a few lessons back. Okay, now we use sample space diagram to solve probability questions. Okay, I showed you how to do these and how to use them. So I've shown you how to do like two heads, a coin and a tail, a coin and a die, and two dice. Okay, so at times you need it so that how complicated the question is, you can use the sample space diagram to help you make sense of the question in front of you, so that you can answer the question right first time. Okay, because it's the same question, it's just that they manipulate it and twist it a bit. So if you have the sample space diagram in front of you, and you can easily see the outcomes you want and use it to solve the question. That is basically it. But if you write it and you use it and do it in your head, you might get muddled up and get the wrong answer. Then I went on to talk about mutually exclusive events that will not happen at the same time. Okay, I explained this at length. So by now, you should know what a mutually exclusive events are. Okay, so if you throw a die, you can only get one outcome. If you throw two dice, you can only get one outcome in a throw. If you throw a die and a coin, you can only get one outcome. So you can get a head for the coin and maybe a 5 for the die. But you can't get more than one outcome. You have to throw it again to get a second outcome. That's why we use sample space diagram to list all the possible outcomes. Okay, so I hope I'm clear on that. Today's lesson, okay, today we want to look at relative frequency. Okay, it's similar to what we are doing. So for instance, if it's in an election year, they will say that, oh, this person is 14 points, this party has this point, they did a survey, this, all that is relative frequency. Okay, now this depends on the sample size and the sample they got. Okay, so if you the people are not going, they're just going to answer the questions. Okay, so for if you don't know the people and you sample like 100 people and they give you their opinion and you give it to us, and then they calculate it, and then they say that, oh, this person, but assuming they should go around and ask everybody from door to door in the whole nation, they will get different results. Okay, that's why at times some of these predictions don't really come true, because the people they are asking might be biased, or maybe they ask more of one party than the other. It's not their fault. It's because those are the people who answered, and that is the result they've got, and that is what they are telling us from what they did. Okay, so relative frequency estimate probability based on experimental data. Okay, so it's an experimental data, it's not like a true data. Okay, because another day, if they change the sample, that result might change. Okay, or to predict how an event or an outcome will happen based on the experiment results. Okay, so let's look at our question for today. Our example: a survey of 500 students and parents. Okay, that is when, so they sampled 500 students and parents. 320 said they are happy with their learning progress. Okay, so it means the others are not happy. 180 is not happy. Now, therefore, what that statement means is 320 out of 500, okay, becomes our relative frequency, because assuming we sample another set of parents, okay, it might be less or more. Okay, or if we sample all the parents and students in the country, the value we get, or the percentage or the fraction we get, might be less or more. Okay, so if I take the 0 off, I'll get 32 out of 50. Okay, now if I multiply by 2, I get 64 out of 100, which is 64%. Okay, which is 64%, depending on what they are asking to leave our answer in. But if I say 64% here, because anything over 100 is 64. Okay, so now, or you can do 320 over 500 times 100. Okay, now this 64% is a chance of picking a student or a parent happy with their learning progress. Okay, so from this data, this particular set of data, 64% are happy. Okay, so it means the rest 32% are not happy with their learning progress, but 64% is a very high percentage. Okay, so it's a bit okay. It's okay, but to accuracy depends on more data. Okay, I can't stress that enough. Okay, people use 4 data, 5 data. 500 is a lot. 500 is better than 100. Okay, if 500 is giving us 64%, okay, it's better than 100 students and parents. But assuming we are looking at 225,000 students and parents across the whole nation, north, south, east, and west, not just maybe in one location, but a sample across the whole nation, okay, all kinds of neighborhoods. That will give us a more accurate result, okay, because even with the 500 that we just saw, we don't know what neighborhood is that. Okay, so it can be a middle class, it can be the rich neighborhood, it can be the poor neighborhood. But assuming our sample is like 25,000, okay, or 100,000, and it came across all kinds of neighborhoods, across the whole length and breadth of the nation, and we got 64%. That would be a very good relative frequency results. Okay, so this is like an example of relative frequency. It comes from an experimental data. Okay, now let's look at the second question, and this can come, this is under probability. Okay, so this can also come, but as I said, you should know this one. You don't need to draw a sample space diagram. All you need to do is to get the result, and if they ask you to explain it, you just say that, well, 64% are happy and the other 34% are not happy with their learning progress. Okay, but if they don't ask you and they just say fine, you get your answer. Okay, you can leave it as a fraction or a decimal or as a percentage, because with percentage, when I say 64%, it makes more sense than to say 320 out of 500. Okay, so when you say percentage, then everybody is like, oh, okay, that is a good now and results. Okay, it's above 50, so it's good, we can accept that. Now the next example, Oliver and James had a free afternoon. Okay, they had a free afternoon. Okay, maybe they didn't want to go out and play, or they didn't want to do anything, or do games, or go on watch TV or anything, but they had a die. Okay, so they came up of this idea of just throwing the dice. Okay, so when they threw the die, they would tabulate it. So after the 700 throw, okay, they tabulated these results. So this is also an experimental data. Under different circumstances, they could have had a different throw, but they were not biased here. They just kept on throwing and tabulating. Okay, so after the 700 throw, they tabulated these results. What are the experimental probability of each number on the die? So this is what they had. So on the die they had 1, 2, 3, 4, 5, 6. So after each throw, they'll throw and do a tally. So the frequency now for getting a 1 was 59. Okay, the frequency of getting a 2 was 118. The frequency of getting a 3 was 37. For them, with this, what they did, they got 138. Okay, for 5 they got 142. For 6 they got 206. Okay, I told you this sign is called sigma. So sigma f, that is the total, the summation of the frequency, is 700. I checked. So if you add everything here, they had 700 throws. So it's 700. Okay. Now, the probability that the throw resulted in a 1 outcome is 59 out of 700. Okay, so you see the difference now. If you throw a die once, okay, the probability of getting S1 is 1 out of 6. But here, they've done it 700 times, and it's their experiment, okay, and they've got 59 out of 700, so that is it. So 59 out of 700. When you use the calculator, you get 0.08 to 2 decimal places. Okay. Now, if you multiply by 100, you get 8%. So 8% of their throw was a 1. That is what it means. Now, the same calculation, 108 over 700, because they had a total of 700 throws. So use the calculator again. They get 0.17 to 2 decimal places. Multiply by 100, you get 17%. So now you are seeing a picture here. So looking at 59, you wouldn't know it's 8%. That's why it's called relative frequency. But just finding the probability of their outcome from the experiment and multiplying by 100. Now you know this is 8%, which makes a lot of sense for you than 0.08. Now, with a 2, they got 17. With a 3, it's 37 out of 700. And then to 2 decimal places is 0.05 times 100 is 5%. Okay. With a 4 there, they got 138. So 138 divided by 700. Now this is 1 decimal place, because when I did it to 2 decimal place, it's 0.02. 0.20. Okay, so I thought I'll just leave it in 1 decimal place, because the question didn't tell me that. Okay, so now when you multiply again by 100, you get 20%. The 5 gives you 142. So look at it, 138 and 142. So if this is 20%, this will be basically around 20% too, or a little bit more. Okay, so 142 divided by 300. Now this also to one decimal place is 0.02. Okay, so if you multiply by 100, it's 20%. Okay, now probability of getting a 6 is 206 out of 100, which is 0.29 to 2 decimal places, times 100 is 29%. So if you have a look, probability of getting a 1 for them is 8%. To get a 2 is 17%. To get a 3 is 5%. To get a 4 is 20%. Okay. To get a 5 is another 20%. And to get a 6 is 29%. Remember, we round off to 2 decimal places, okay, so that to make our answer neater. So I have written it by the side. Okay, now when I add all the answers I got in percentage, I got 99%. Okay, so the running up and down 2 decimal places, 1 decimal places, made me a little less than 100, but it's nearly 100. Okay, so it means it's right. Okay, so look at it now. So Oliver and James afternoon, they realized that with the experimental throw they did, okay, they had 8% for a 1, 17% from their table, okay, for a 2, 5% for a 3, 4% for a 4, another 5% for a 5, because 138 and 142 is just 4 throw difference, okay, 29% for a 6, okay, so that is nearly 100% there. Okay, so this is another way they can twist questions at you in the probability questions. Okay, and you have to be some, because here you don't need a sample space diagram, even though you know that the probability of getting a 1 is 1/6. Here they've done an experiment and they're asking you to use those values, okay, to find the probability of each outcome. Okay, so this is how they are able to predict some of the points in on TV. So they tell us that they sampled 100,250 people across this place, and this is the percentage of this candidate or this party or this other party. So the party sees it. That's why at times, after we've gone to vote or after an election, you don't really get the results that they have predicted, because they just sampled it in a smaller space. So for instance, with James and Oliver, I don't know whether they were lying down. I don't know. They did it. They just kept on throwing. Okay, but to do it for 700 times, that means they did a lot, because somebody could have done 70 or 20 and use it to calculate, but after 700, this would be a fair result, okay, of their finding. Okay, so today I've shown you another way of solving probability questions using relative frequency. Okay, so it's not only the ones we've been doing, it can be in another way. Okay, so you have to read the question carefully and see what they are asking you to do. I can't stress that enough. Okay, if you don't read the question properly, you might do something else. Okay, that is right, but you've applied the wrong principle to solving another question, so you might end up with the wrong answer. Okay, so if you know what they're asking you to do and you answer it, these are simple things you can get on top of your head, especially if it comes to the calculator paper. You can easily use the calculator and get your answer right. Okay, depending on what they are asking you to do. They might not ask you to do all this, okay, but I just did it to show you, okay, how to show how it adds up to 100%. Okay, so thank you so much for watching today's lesson, and I'll see you in the next lesson.